Hi, I'm Ichi, a PhD student at Aalto University. I'll be presenting our paper, Rediscovering Affordance, a reinforcement learning perspective. Upon seeing this object, what action do you think it allows? Yes, the answer is press. But have you ever wondered, how do you know that? Usually, we attribute this ability to affordance. Affordances refer to the actions available to an organism in an environment. It is also a fundamental concept in GCI because it explains how users know the reactions for each object. For instance, you can tell a button affords pressing, a handle affords turning, and a dial affords rotating. But how do we learn affordance in the first place, and how do we adapt it in daily interactions? Let's take a look at the previous views. For ecological psychologists, affordance is built upon body relative features. For instance, this object is traceable to you because the dimension of the keycap somehow matches the dimension of your fingertip. Also, the depth between the keycap and the base compared to you is sufficient to be pressed down. So you recognize it can be pressed. The other perspective is from machine learning. To them, affordance is a classification problem. That is, you know this object is traceable because you are able to classify it based on the visual features and details. So there are two perspectives so far, yet none of them explains how affordances are learned, or explains how we adapt affordance from interactions. The theory we are proposing is from reinforcement learning perspective. In a nutshell, our theory believes affordance is not innate, but highly adaptive and learned via experience. By trying out interactive things, people become better at estimating what they can do with their bodies in the environment. Now let's dive into our theory. In our view, the core of what we call affordance is an estimate people generate for values of possible actions. People simulate motions in their minds when seeing different objects, and further estimate the value of these simulated motions. Take a door handle as example. What are the actions you can think of? Well, you may think of pushing it, swiping it. If you want, you can also punch it, but perhaps the most sensible one is to turn it. We can simulate these actions in our minds and place a value on each of them. For instance, pushing a door handle requires force, so the value might be -2, and swiping over it probably costs nothing, so the value is 0. Punching it will make your fist hurt, so it's a -10. Lastly, turning it will give you an opportunity of opening it, so the value is 10. Because you are able to generate the value of each action, you are able to recognize what are the correct ones on the object. The second principle is that affordances are learned when the outcome, also known as the reinforcement signals, are provided in response to motions. Remember this handle? Well, we previously mentioned that you can generate the value for each action. And the reason is that we have interacted with handles a lot of times in our lives. And sometimes we did the right action and received positive outcome. And some other times we might do it wrongly and received negative outcome. These experiences gradually shape our behavior and let us know the most valuable action should be performed here is to turn it. Thirdly, there are two strategies of learning motions and affordances. If a user fails, they generate alternative motions. If they succeed, they keep using the same motion. Take my keyboard as example. I know this object affords pressing because I have pressed this keyboard many times before. And I also know that I can get a good outcome by taking the same action, which is press. Such a strategy is called exploitation. A user can exploit the known knowledge to achieve the best outcome efficiently. However, sometimes we encounter new things. For example, a traffic light button. What action do you think it allows? Well, my first attempt is to touch the point where a hand is drawn. And this is the outcome. It is a negative signal. My second attempt is to grasp it and squeeze it, and it is the same outcome. Eventually, I found out I need to press the button, and I finally acquire the positive signal. Such a strategy is called exploration. When facing uncertainty, we will attempt various motions in order to acquire the optimal outcome. But once you've learned that, we can exploit the learned motions to be more efficient. Our first principle is that affordance can generalize to unseen objects. Let's pretend this is the first time we see this kind of keyboard. It is very different from other keyboards because it is very shallow. However, you can still tell it's pressable, right? The reason behind is that you have encountered so many pressable objects in your life. You learn to generalize your knowledge and find out a right mapping between certain visual features to certain motions. Lastly, humans are able to associate linguistic labels with affordances. For example, you know this object is pressable not just because you know how to create the motion, but also because you know this action is named press. While the linguistic labels are not essential, it provides benefits in reasoning and communication, especially communication. We all have seen objects that we don't know how to use. For example, this round-shaped object. You can simply ask others, and someone who knows will just tell you, rotate it and press it. Without demonstration, you can already get an idea and simulate the action in your mind, and further actually implement it, such as rotating it and pressing it. To summarize our theory, we believe that affordance is highly adaptive and learned by experiences. The source of affordance is the estimated value of each motions that we simulate in mind, and we learn how to simulate these motions and estimate values by exploration and exploitation and generalization. We conducted 2 user studies and built a robotic model. Please take a look at our paper for more details about the user studies and their findings. Similarly, please read our paper for more details about the robotic model. Finally, we've come to the discussion. The essence of our theory is that affordance is adaptive and learned by experience. Our theory aims to establish a new common ground for HCI. For example, the term has spread meanings in the field. Our paper provides a concrete understanding about where affordance comes from, based on which we can build more actionable discussions. Also, there are various types of affordance in HCI, and based on our theory, all kinds of them are learned via the same mechanism, which is reinforcement learning. Finally, our theory answers what is a natural interaction. In our view, even the most intuitive action is once discovered, learned, and constantly adapt. And natural interfaces are simply the ones that the assumed motion lead to the predicted rewards. That's all my presentation. Please check our paper and project page for more details. Thank you.